tides are another example of things that are cyclical in nature. The tides go in, the tides go out. The tides go in, the tides go out. The tides go in, the tides go out. And anything that's cyclical in nature, what you can do is you can take data from that, you can graph it, and it will make a sine or a cosine graph. So in this question, we've got only 2 data points. We know that the maximum depth of the water is 8 meters at 4:30 a.m. and 6 hours and 12 minutes later, it's at a minimum at 2 meters. So when drawing this out, I'm going to put my depth here. I'm going to put time here. And if I'm marking 4:30, you know, those 2 little dots are not very easy to put into your calculator. What should I put for 4:30? 4.5. And how did you decide on 0.5? 30 minutes is half an hour, so 30 out of 60 is 0.5. And so I have one data point right here. That's my maximum. 6 hours and 12 minutes later, at 10:42, I have a minimum of 2 meters. Well, 2 is pretty easy to put on here. What am I going to put down here? 10.7. Now, a couple of things to be careful with, okay? As soon as I put that 4.5 down, my 10.7 that I'm going to put next has to be properly placed, give or take. They're not going to take a ruler out and measure, but why would 10.7 be bad to put there? This is 4.5, and this is 10 point, like that's another 6 after that? Yeah, no, that's bad. So I would sort of have to estimate, well, 10.7 is 6.2 after 4.5, and if this distance is 4.5, I have to make a distance that is at least reasonable to be another 6.2. So I'm going to, that looks reasonable. I'm going to put 10.7 here, and I can label this dot. And this is the only data that we have. But because it's cyclical, because it's periodic, and it repeats itself, we should be able to say, I know when the next maximum occurs. Well, I know that it's going to be at 8. That part's the easy part. What's the x value for that next maximum? Oh, before we get to that, I'll let you think about that. 10.7. How did we get the 0.7? How did 42 change to 0.7? 42, if we look at what percentage of an hour that is, 42 out of 60 minutes. I mean, without a calculator, you could reduce that to 7 over 10 to get 0.7, or you could type it into your calculator to get 0.7. So first of all, that's where we got our 0.7 from. But we're still now looking for what am I going to put as my next x value for that next maximum. And how am I going to figure that out? Any ideas? $16.9. And how did you come up with 16.9? So this to here was 6.2, and if it is periodic, this will be the exact same amount, which will be another 6.2, which will get us to 6.9. How do sine and cosine graphs work? Well, once you had a full period, we always divided it into 4 equal sections. So if from 4.5 to 6.9, from one maximum to the other maximum is one full period, that would need to be divided into 4 equal sections. It's already cut in half. We could add these ones in. half of 6.2 is 3.1. So this one will be 7.6 and this one will be 13.8. What also do we usually have on a sine graph? Well, we usually have a center line. Well, I'm going to take a wild guess that my center line is in the middle. And I can label this, well, what's right in the middle between 2 and 8? 5. And so at 7.6, it will be at the center line. At 13.8, it will be at the center line. And here is our graph. To get the equation of that graph, and this question said get one equation with sine and one equation with cos, we have to think about dab C and get as many values as we can. Again, once you've drawn that center line, your d value is really easy to figure out because your d value is your center line. It's going to be 5. Your a value is your amplitude. Well, from 5 up to 8 or 5 down to 2 is 3. Your b value is based on your period. Remember that your b value is 2 pi over our period, and in this situation, our period, well, if it's 6.2 from the maximum to the minimum and another 6.2 from the minimum back to the maximum, from one maximum to the other maximum will be 12.4. So our b value will be 2 pi divided by 12.4. Excellent. Now we're going to write two equations, one with sine, one with cosine. And the thing I want you to realize, and that we've done already with creating equations with DAB-C, is that the d, the a, and the b value do not change. Whether it's sine, whether it's cosine, whether it's a negative sine, whether it's a negative cosine graph. The d, the a, and the b values stay the same. So we can start writing everything out except for the c value. It's going to be a is 3 sine, b is 2 pi over 12.4 x, and then our d value is plus 5. Same thing for our cos graph, 3 cos 2 pi over 12.4 something plus 5. So now we go to our last part. If we're creating a sine graph or a cosine graph, we need to find our c value. And our c value is our starting value. A sine graph starts max, min, middle going up, or middle going down? Middle going up. So if we look at our graph, do we have any points on our graph that are on the middle going up? There's one right here. So I'll use that value. You also have one right here, but we don't have that one labeled. So since I have 13.8 labeled, I'm going to go down here and say it's 13.8 to the right. So that would be minus 13.8. If you wanted to label this one, you could have. What would the x value be here? 1.4. Because it's 3.1 in between each set of ticky marks. So if I subtract 3.1 from 4.5, I could have also used minus 1.4 there. So there's more than one right answer. And on an exam or a quiz or a test, any correct answer is accepted. For a cosine graph, where does a cosine graph start? Max, min, or middle going up, middle going down? Starts at a max. You could use this one. You could use this one as well. Both are correct. Both are labeled. So I'm going to use the 4.5. That means our graph has been moved 4.5 to the right. Now, just like yesterday, you could take one of those graphs, put it into your graphing calculator, set your window up to see this exactly and then be able to solve other questions. In part B here, it says, estimate the depth of the water at 1:30 p.m. So the first thing we have to figure out is, where does 1:30 p.m. fit on our graph? Right? 13.5. It's not going to be at 1.5 because this 4.5, when we put it in, was 4:30 a.m. So we would have to go to 13.5 to get 1:30 p.m. And if we went up from that and had to do an estimate, $4 meters seems like a decent estimate. If we wanted to find it exactly, we would type things into our calculator and input a value of 13.5. So I'd like you to try example 1 for practice. At the bottom of your page, I think it says a bunch of exercises. I'm not going to give you those, so you can put a line through those. But if you want some more practice out of your textbook, you can do questions 3 through 9.